Hello, this is Kyle Scott reporting in for the written section of test 3. Alrighty, so they want to know which terms are associated with Patu syndrome, and that's going to be trisomy and autaploidy. And it's trisomy 13. And I don't think any of the other ones apply. And then for number B is which ones are associated with the conventional form, not the familial form of Down syndrome. And that's going to be non-disjunction, trisomy, which is trisomy 21, and aneuploidy. And it's non-disjunction because that's how it gets the 3 chromosomes in chromosome 21. And thinking back, Patu syndrome is probably going to be non-disjunction too. For 1C, it's which of the above terms is associated with Turner syndrome, which is when the girls just have the X chromosome and they don't have 2, just 1. That's monosomy, autaploidy, and non-disjunction. For 1D, what of the above terms is associated with Cry-du-Chat syndrome? And that's going to be the terminal deletion in chromosome 5. Which of the terms is associated with type A hemophilia? And that's an inversion on the X chromosome, which causes type A hemophilia to occur. Number 2, we want to indicate the polarity of the primers on the images below. And I have already put the polarity on these primers. And I just took the huge chunk that we got and found the places where they matched up, and that's where the primers went. They want to know what the DNA sequences will be synthesized between the primers, so I just copied the middle section in between the primers, and then I just found the complementary DNA, which would be the new DNA made off of that template in between the 2 primers. For part C, they want to know which direction, right to left or left to right, is the replication fork moving. And it's going to be moving right to left, because if it were going left to right, then we would have a leading strand and not the 2 lagging, or not the lagging strands. And for part D, which of these 2 primers were synthesized first? And that's going to be primer B, because as we split this way from left to right, it is going to run into primer B first. For part C, they want to know what are the 4 products of meiosis when there's crossover between T and U. So I just put a bar in between the T and the U's to help me find out which of the daughter cells is going to be. And we know there's going to be the normal parents. So right here we have the normal healthy and the normal inversion. And then this bar is really helpful because you're going to start at one end and loop you around. You get to T and you go up to U, and that's going to be the short acentric one. And then you do the same thing for the long dicentric unhealthy one. For part 4, we want to find out, well, here's just some preliminary knowledge. They give the 1+ site shown in bold. And this DNA right here, these are attached together. And so they want to know which one is the template strand and which one's the coding strand. And the lower one is going to be the template strand because it has the A, and that's what the 1+ site usually has. And then the top one is going to be the coding strand. And so they want to know what is the sequence of mRNA molecule produced from this DNA molecule. So we start at the transcription site. That's going to be our first nucleotide process that I just went through and went all the way down to the end to find our mRNA molecule. And they want to know where the -10 and -30 sequences are located. And that's going to be left, as that's before the start site. So those are promoter sequences. And in number 4D, in which direction, left or right, along the coding strand relative to the first prime site would the terminator be located? And that's going to be on the right, because if you terminate before you start, then that's just not going to work. All right, thank you. I hope you enjoyed it.